with the engine stripped down, now we're going to have a quick inspection of what it's like. Now, a lot of you haven't got equipment like this to measure the bores, so sometimes it might be just as easy, if you're going to work on an engine, pop it down to your local engineering shop who does machining and things like that, get them to check it, you know, because you can never, you know, I found this little set on eBay many years ago, and it's good, but what we do is we measure in the bores, and we measure in them this way, yeah, it's not me, there was a bit of carbon on there. We're going to measure them at the bottom, and we're going to feel to make sure that these are parallel. We're going to do all four like that. Now, the reason why we do that is that cylinder bores can go like pear-shaped, so they look okay at the top, but in the middle they can be worn, and that's because of the piston. When it comes down off its arc and comes back up the other side, there's a little period there where it's pushing up the side of the piston, side of the cylinder, and it can wear it out. Now, these bores are particularly good. They are actually oversized, so that's a good thing, because I looked at one of the pistons this morning to find out what size it is, and typically there's no marks on it, so it is actually 1/10,000th of an inch oversized, which isn't too bad. I've checked all four, perfect, so we don't have to worry about that. Now, one interesting thing I was looking at in the Land Rover manual this morning was that it says you don't deglaze the bore. Now, that's very odd. Usually when you put new rings in, you have to deglaze it, and they said no. Don't know about that. I'm going to deglaze it anyway. What a rebel. So we've checked the bores. That's fine. Just one little thing. These are all this old-fashioned things in inches, but what I do, I cheat a little bit because I want to know what it is in metric, and rather than converting it, wait a minute, I look on here. I put the vernier on it, and it should be 90. Wait a minute. Let's get this right. It should be 90.73. You see how difficult it is to do with the vernier? Yeah, there you go, 90.73, and that is 10th hour oversize. You have to get a feel with the vernier. It's a lot better with a micrometer, but as if anybody knows, you could read off this in inches, but it has, you know, it's not the easiest thing to do because you've got little extensions on here. So that's easy, that's good, that's the bore done. Like I say, if you're not sure, take it down to your machine shop. The next thing we're going to check is all the threads. We're going to look around everything in this block. So let me have a look, and I'll show you ones that really go quite common. There's things on these Land Rover blocks that are stripped off and taken off quite frequently. One of them's this little triangular opening here for the water passage, where the water pump pushes water around the block, and these can either strip out or get damaged because they're very close to the water, and water can actually get in through the threads and rust them up, sometimes stripping them out, sometimes snapping the stud inside. I've mentioned this before when we do the P gaskets. Just pay attention to these when you put these together, to drain the block preferably before you fit any bolts in here, because the thing is that if you get any water in here, you can crack this casting. It's very thin. The rest of the things are not too bad. I'm going to change the front core plugs. I was almost going to call them frost plugs there, but I'm going to change the core plugs. It's already got a block heater in. I can't get it out. Once these are in, that's it. Take a note of the position. It's almost sort of 1 o'clock, and the arc is pointing towards 1 o'clock. All right, so that's if you want to know about that. Obviously, we're going to replace all joints and things like this. What else is there to look for? Now, we need to have a look at the cam bearings. Now, I have never changed cam bearings on a 300 TDI, apart from dropping that down. But the one bearing that I have changed is this one, because, let's put them in my pocket, the cam bearing here can wear, if the belt's too tight, it pulls the cam across and makes a groove. Now these feel nice, there's no groove in there, so I'm quite happy with that. But I have found a step in this one before, but the other ones are fine. Hey, tell you what, let's get the camera out and shove it down there. Ooh, the old camera, and we can see what the rest of the bearings are like, because they're very difficult to see and even more difficult to measure. So I got my camera out and I put this little adapter on that goes with the mirror, and so I could show you what I can see in this block. To tell you the truth, it's worse than useless. But I can take the mirror thing off and have a look inside. But the problem is I can't really see much because I can't turn the camera around at 90 degrees. And anyway, it's a waste of time, because I found out that by using a regular flashlight inside here, 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 and the front one's really easy to see, you can see the camshaft bearings in place, so you can see if there's any wear on the bearings. If they look nice and even, then they're okay. Now, one really important thing about the cam bearings is that they've got drillings in them, and the drillings are for the oil ways for the crank and other bits and pieces. It's really sort of, well, it's not really for the crank, but you'll sort of get my drift. But the idea is that there's an oil passage in the block that goes to feed the cam bearings. Now the problem is, and this is kind of really serious in some respects, that especially on the 200 TDIs, the rear bushing for some reason used to turn in the block and block the oil passage off. That's not good. So what we want to try and do is get inside there with a flashlight and see, and it's quite easy to see actually, because the hole's down at the bottom, it's drilled, and that's what these holes are actually for, because they plugged them up later. But that's what these holes are for, to drill a block through for the camshaft. So that's easy. Check them with your fingers, make sure they're nice and smooth. If there is a little bit of discolour or something like that, don't worry about that too much, because when the cam's running, it's actually pushing to one side, so it's not always running, you know, right round the bushing. It just wears to one side. But what you're looking for is any great big gouges and things like that. I know it's a bit complicated, but after all these years, when you just look at them, you know what they're like. If you have any doubts, take your block down to a machine shop and get them to check it for you. Now, one of the common problems with a 300 TDI, and not so much a 200 TDI for some strange reason, is that this front bushing here, it wears out. It gets a groove in it. Now, the thing is that I don't know if you can probably see down there, there's a hole that goes through the block, and it's drilled from underneath this way. And you can see where oil comes from this passage and up this way. But the thing about that is, because you've got tension on your belt, and sometimes when it's too tight, this cam can push across, and it wears a groove in the bearing. No big deal, you think you wore a groove. Well, the problem with that is the oil pressure, the oil will leak out through the side of the groove, because think of it, it's just like an egg. It's not completely concentric, it's sort of egg-shaped, so the narrow bit is where the oil will squirt out and lose pressure, so you need that to be nice and tight as possible. It is difficult to replace cam bearings, and again, down to your machine shop if you want, but I had this little tool made by my friendly machine shop man, and it's a guide for putting in the cam bearings, and simply you push it in like this. You put your bearing on this guide, line up the hole, most important, and then you can tap it in. Now this shoulder here will come across the end of the block, so you know that's nice and square. But again, for the price it costs to make this and stuff like this, if you take it down to your machine shop, say put a set of cam bearings in there please mate, and they'll do it in next to no time because they've got all the tools and equipment to do it with. If you've got any problems with loose cam bearings, it's a new block. I don't think there's much you can do with it. Probably you could, but the cost is just outrageous. So I think we've mentioned we're going to pull the glow plugs out, not the glow plugs, the frost plugs or the core plugs out. We're checking around all the threads, all the oil passages and things like this. We're going to shine a torch down inside there. We've got the back open so we can have a good old look around, see if there's no gunge or gunk in there. Probably this won't be applicable to British type people, but in America you can get nice gun cleaning rods and you can push them through there and push them out just like cleaning out the barrel of a gun. But really, if you've got a good power washer or parts washer and get that all cleaned out, really there's no need for that. What else is there to notice? That's about it really. The blocks are really simple. There's nothing, I mean, you could check for cracks and things like this, but dear me, it's very rare that these blocks cracked. The turbo diesel's cracked, but these are quite good. We've got a good reputation for that type of stuff. So what we're going to do now, satisfied that this is okay, we're going to move on and have a look at the pistons. We're going to start to have a look at the pistons now and see what's wrong with the pistons and rods, if anything, and things to check. Now we know that this engine had lost a bearing on number 3, and this is the actual offending item. And I don't know if you can see down here, but this bearing is quite discoloured, where it's been discoloured in here. It's quite bad. And I'm suspecting that this bearing, when we put it together, isn't quite round. I think it's gone a little bit oval, so we're going to check that. But there's one or two things you've got to know when you're assembling engines and bearings. Firstly, you see they've got this little notch in here. Well, when you get your bearing shell, that's the location spot. That stops them. It not only keeps it located from moving left and right, but it also stops them from turning. And that's very important because sometimes bearings can spin in the housing. Now we were really lucky with this one that it didn't spin. So hopefully when we measure it, it should be okay. If it isn't, we're going to have to machine it. And what they do for machining is they very lightly grind off this surface here on the cap, put it together like so. This is a bit tight, I don't know why this is tight, but anyway, they're going to put that cap together and then they'll bore it, they'll hone it to the exact size, and I'm going to show you what they measure. You'll notice too that there's a notch in here and in the cap. Those two always go together and they always will do. And you'll see there's a little bit of discoloration where this one went. And the same on here, you can see the discoloration where it's where the gap is on the other rod. So we're going to put those together. And I don't know why they're a bit tight. They should just slip on. And then we're going to tighten up the nuts to the specified torque, and we're going to measure that. That's a bit boring, tightening nuts up, so we'll come back in a minute. So naturally my eBay kit didn't come with all the attachments for making a very small internal micrometer, and this is in metric, which is a bit of a shame. So what I've done is I've just found a piece of drill bit that fits into the end of here, so we can measure the internal size of this big end here. So I've got it in and miking it up there, look, and that feels just nice. And It's not bad there. It's, ooh, let's see now. That is now obviously the measurements on this aren't going to work very well because I don't know what size this pin is. Like it can go in and out. So there's no shoulder on it, like there is on these ones here. There's a shoulder, so we know what that's the set height. So we're going to use our friendly inaccurate caliper. Turn it on, zero it, and let's see what it says. 6240. So 6240 millimeters here. Now, obviously, why we're measuring here is this bit won't have had any action. This one won't have gone oval, if you see what I mean. So we measure it even so. We'll measure it here. This, well, maybe it's a bit. It's difficult to. Oh no, I see, because it's dropping in the hole. Wait a minute. It's not 6240. Here we go. You remember that slot I was telling you about? Well, it went into there. It was giving me a wrong reading. Sometimes you have to have the patience of a saint with this thing. There, so let me see what that is. 6230. Now, because we know this is standard, if this is worn, if this is oval, this will be a little bit larger. Can you hear? What did we say? 6230. Six two four one. A little bit bigger. So I'm going to measure up all the rest of the rods, but this one in particular, we know that it's got a little bit of oval because this is kind of weak, this piece, because all the power goes through here. Well, it's a little bit weak, so when it's rattling about, it'll be banging about at thousands of RPM per minute and just stretching that cap. So we're going to take that down to the machine shop and just let him have a look at that. I don't know if my machine shop can do it or the automotive machine shop. Well, they're kind of expensive and they make everything out to be a bloody, you know, what was it? Don't turn a drama into a crisis. Well, that's what they do. So we know that that's out. Let's have a look next at pistons and what you should notice for a TDI before I put it in the vise. You'll notice on the rod here it's stamped with a number 3. Well, there isn't any stamping on here because for some strange reason they stamp it here. Don't know why they do that. But again, these two always go together. The numbers always go together, so don't forget that. Don't put it on the other way around. Because you see, because these are bored, when the machining is done, these are bored concentric with the rod, if you see what I mean. If you turn the cap over, you'll find that it might have a little step, and that's not good. You don't want that. And again, another thing to feel inside, if there's any steps, and there shouldn't be anything at all. So the number here, it points to the thinnest part of the piston. You see, the pistons are actually offset, they're not in the centre. So that number goes with this thin bit. Always remember that when you're fitting your rods to your pistons. Next thing, pistons themselves. I was taught this a long time ago, and I've sort of stuck with it ever since, and I've never seen one come loose yet. But the gudgeon pin, in American they call them wrist pins. I don't know why, but anyway, that's Americans for you. The closed gap should go at the bottom. All right. Not at the sides, because if that gap was at the sides with the engine going up and down, that gap that can actually become unsprung, and I have actually seen it where those clips have come out. So if you put them at the bottom, they haven't got a hope in hell's chance of coming out. Also, whilst we've got this in a vise, I checked them on the block, but you're going to check if there's any play, any loose in those pins. There will be some side to side, but you want to make sure they're good up and down, there's no play in there, and the bush is good. Next thing, rings. Now the rings on TDIs are not too bad. They don't wear out too much, but, well, I say that, high mileage ones do, and I'm going to explain why. Inside the top of the piston, when these pistons are cast, they actually put a steel insert in the top, because the top of the piston gets an awful lot of... Well, my battery went flat on my camera, which was a bit of a disappointment. Anyway, so I don't know where we got to, but let's see if I can edit this together. We've mentioned the gudgeon pin, the circlip holding it in has to be at the bottom, not at the side. We were talking about the rings. I'm sorry I'm having to go through this because I can't remember where I was. Top ring, fire ring, protects the compression ring, and then you've got your oil control rings. Now your oil control rings are funny little things. I'm going to try and get one out. Let me try and get one out for you because they are super delicate. Now I'm taking it off from the bottom. And let's take this out and lift it up a bit. They are fragile. Alright, so let's get this out. Now obviously I've been steam cleaning it. It's a little bit, got a bit of rust in it, but it doesn't really matter. I don't know if you can see inside this ring, it's actually hollow and it's got a spring on the inside. Obviously we're going to put new rings in this. This is why I wasn't really bothered about this. But you can see in here there are some slots, and that allows the oil from the piston when it's coming underneath. So oil that's been splashed up on the side can actually go down inside the ring and back through the piston. Let me take off this spring. The spring's there to just push it out a little bit, and it's got a wire in it. You see, when you assemble it, it's got a wire that goes into there like that. This isn't too bad. This will clean up if you need to use it again, but again they come with a kit. So when you're doing an engine, it's wise to take off the rings and clean out the grooves. Now the grooves on here, they've got little holes in the bottom of the piston. I don't know if you can see here. So that allows oil to go down and back into the piston. I'm not sure if we can see a good description of that. I'll tell you what, let me go and get a flashlight and I'll show you the holes. I've got my torch out and I'm going to show you. You can probably see inside that piston there is a series of holes. Now they're not all that fantastic. There only seems to be two of them. Is there ones in here as well? No. Now these are aftermarket pistons, these aren't originals. I'd like to see if I can find an original, but it's got the makings of an oil hole here, but they actually aren't. It's only relying on these two. I wonder if that's why they're aftermarket ones. Anyway, the oil is supposed to go through the ring and drop back down to the bottom. Now, if you want genuine pistons, be prepared to sell the kids because they're very expensive. Now, as I was mentioning, I'm going to take these off of my fingers because I've got nothing to lose. And it's not advisable to do this. I've got a tool coming. I'm going to show you what to use, and the tool to put the rings on and off is really cheap, and it saves breaking them. But like I say, inside here, if we can see, there is a steel insert inside the piston. And that, like I said, that because the piston's hammering up and down, it's got fire and heat at one side and cool oil at the other. There's a lot of temperature things going on here. Now, some of the old engines, and I think this one one's the same. Yeah, this is the same. If you can see the profile of the ring, it's tapered. So that means when it goes into the ring, it's tightening up. That wall the taper is pushing into the ring. Now what happens a lot in these cases of piston rings, and especially in high mileage engines, these get thin because it's been hammering up and down in that steel. It doesn't necessarily mean that the piston's worn out, but the rings can wear out, so just be aware of that. Now when we put the rings on, we're going to put them in a step pattern. There's no point showing you that now, I'm only showing you things to look for. But when we put the pistons on, well, I'll show you the specific pattern that you put them on, because it's really important. And you've got to push these, when you put the pistons in, it's important that you don't have any gaps on the cam side of the engine, because I do believe that the cam side of the engine is the thrust side. I could be wrong, I'm going to look up that, because I'm almost sure, because when the crank's spinning round, it's pushing the piston, if you see what I mean. So you don't want the ring gaps here against the side of the piston. You want the other side, side of the cylinder, sorry. You want the other side, nice smooth side, against the side of the thrust of the cylinder. So I'm just going to cover the block and the pistons today, because these videos do tend to drag on a little bit. And I think we've covered just about everything. If you need to take the gudgeon pin out, or the wrist pin, and to change the bush, machine shop. Get them to do it, because it is a tricky little thing to do and set up. And the wrist pin should be nice and free, but not any up and down on it. And like I said, these pistons were nice. There's nothing really untowards with them. This is the sides that does all the friction. This bit's undercut a little bit, and if you can remember from a previous video, these were all dirty and gungy, so I don't know what caused that. I'm very sceptical about that. But apart from that, you could also, if you've got no problems with your engine and you're just doing a sort of an overhaul, you can put these rods on a flat table and just make sure that they're flat and not bent. If you know, 99% of the time, or 99.9% of the time, the rods are good. But if you've bought an engine on the floor, which I recommend you don't do, if you're going to buy an engine, try and hear it running and pay that bit more. But the thing is, you can actually get an engine that's had water in it, water's gone through the intake, and it can bend a rod. Now I know the history of this engine, so I think it's okay, but it's another thing you can check to see if they're actually straight and in line. If there's any bends in them, bin them. It's too much of a risk to put back, you know, to rebend. It's not worth it. Now I'm just looking under here, and perhaps this is, you can understand, this is why I'm saying to get a machine shop to fit the little end bushes, because it's not parallel, so you don't have anything really to push on to push the bush in. So it's, sometimes you can do it if you've got a lot of experience, you can do it, but generally speaking, again, I don't get much problems with these. They're a splash thread from the crank, and also you've got the jet underneath cooling down the piston, so these get a lot of lubrication, there's a French word for you, and they're usually pretty good. So that's that for the pistons and the block, as far as I know. Next thing, we'll start to have a look at the camshaft and all the other bits and pieces.